Welcome in this PowerPoint about temperature factors. If you haven't done so, please restart this PowerPoint. Click on F5. Once the presentation is finished, you can click on the slide to listen to the next slide and information. This PowerPoint is made because of much of these things that are covered in this PowerPoint probably already were covered in your secondary school career. If not, I recommend you to search on the internet and read Geosystems for more information than I already provide in the PowerPoint slides. There are several factors that influence temperature. Much of these probably already covered in your secondary school, but we will go by these one by one and even add some more on the next few slides. I'll give you a minute to read this, and if you're finished, click on the next slide to hear more. Because of the position of Earth towards the sun beams, the rays of sunlight, they tend to reach Earth in a sort of horizontal way. We will cover more about this in the course Physical Geography at the end of year one. But because they do, you see that once they reach Earth, the moment they reach the surface at a higher latitude, you see that it covers more of the, like you see here, more surface area. Because of that, the same amount of energy needs to heat this part of the Earth compared to the equator. Also, the distance the sun ray takes to reach Earth is at the equator way shorter than it is at a higher latitude. A bigger surface that needs to transfer this energy into heat results into lower temperature. The fact that the sun ray takes a longer time to reach Earth also doesn't help to increase temperature. Actually, it decreases temperature. These two reasons are the reasons why latitude is a very important matter, a very important thing that influences the temperature on Earth. If you look at this graph, you can clearly see that. Near the equator, the temperature during the year, you see the months down here in the graph, January, February, March, etc. You see that the difference between summer and winter temperature is not that big. I mean, it's almost equal. The more north you go in this case, so towards Alaska, you see that the difference between summer and winter temperature is way higher, because in the winter, the sun is not directly above the equator or not directly above the Tropic of Cancer, but it's the sun is where the Tropic of Capricorn is. That is why it's colder in winter. The second factor is altitude. Apparently, the higher you get, the colder it gets. So temperature decreases with increasing altitude. This is because the air density also increases if you increase with altitude. The air is thin, as we call it. That means there are less molecules in the air, and molecules, the movement of molecules is what causes heat to transfer. And therefore the daily temperature range increases with increases temperature altitude. Elevation. We know that the higher you climb on a mountain, the colder it gets. You can also see that in the vegetation of these mountains. For example, here below you see deciduous forest, etc., etc., all the way up until the eternal snow where nothing else grows anymore. So the higher you get, the more colder it gets. The average temperature is 6.4 degrees with every 1,000 meters you increase your altitude. In the weather and climate lessons of the physical geography course, you will learn that this is not always the case, but for now, the average temperature decrease is 6.4 for every 1,000 meters. On this slide, you can see what I just told you. More particles are close to the Earth, and the higher you get, the less particles you have. The density decreases with the increase of altitude. And as I just explained, water molecules, molecules in the air, if they touch each other, they transfer heat. And therefore, the less molecules you have, the less transfer of heat is possible, and therefore it also gets colder. Another thing that influences the temperature, cloud cover. At any given moment, the cloud cover on Earth is about 50%. So that affects weather and temperature. It can affect temperature in two ways. It can either cool down or warm up, and I will explain both of them. The first one is how clouds can cool down. So we see a cloud here. We see the sun sending its rays down to Earth. These rays hit the cloud, and because of what we call albedo effect, which is the more white a color is, the more it reflects the sun's energy. So the rays of light are sent back into outer space. Only parts of it can penetrate the clouds and reach Earth. And this shortwave reflection of the sun needs to reach Earth in order to be able to transfer it into heat. We will cover more of that in the physical geography course, so you don't have to worry about that now. But only if a sunlight hits the Earth's surface, it can transfer the reflection, the shortwave reflection, into a heat reflection. But since nothing or not much of these sun rays actually reach Earth, it cools down the temperature underneath the cloud. The opposite happens if the sun is not there anymore, or for whatever reason the Earth's surface is already very warm. It can also be that the sun is still here during the day, but then the heat was still trapped because of the days before. That can be the case, but in any given case where the Earth's surface is warm, it starts to radiate these long wave radiations. And normally, if there are no clouds, these long wave radiations, they would just disappear into the atmosphere. But because of the clouds, these radiations, they get sent back. And therefore the heat is trapped underneath the cloud. Another very important factor that influences the temperature is the land versus sea. You can see here San Francisco, close to the sea, has well, the differences between the days of the month are not that huge. Whereas in Arizona, which is further away from the coast, you see that the difference between day and night is way bigger. The reason for that is simply this. So, if a ray of sunlight hits the Earth, it will not penetrate this sand very deeply. It'll probably only, well, maybe in best case scenario, only heat up the top part of the soil. Whereas in the water, it starts to heat the water, and it has to heat this whole mass of water from the bottom up all the way until the complete water body is warmed up. That takes a lot of time. So therefore, if during the summer, for example, the wind in the summer the water is still colder than land, because you can understand that this land heats up very quickly. You know this. If you walk on the beach on a sunny day in the summer, in the morning you walk bare feet on the sand on the beach, and you will not burn your feet. If you do the same at 4 o'clock in the afternoon, you will burn your feet. That's how fast land can heat up. But the water temperature in the morning is probably still the same as it is in the evening. That doesn't differ that much. It takes several weeks for water to warm up. So if the wind would come from sea and blow towards land, this temperature here will probably decrease because the water temperature is 18 degrees. The wind that's blowing towards land is also colder than the 25 degrees, probably 19 or 20 degrees. So it will probably have an effect on this land and cause the temperature to drop maybe to 20 or 21 degrees. That is how water and land influence each other. By the way, in the winter, the opposite is true. Then the land is cool, and then the water is still, compared to the land, warmer. It's all relative, and then it can have a positive effect on the temperature on land. You can see that in this picture. This picture is a bit more clear and explains a bit more, and this comes from the Geosystems book. So if you need more explanation on this topic, please read the book. Another thing that is the jet stream also influences the temperature a lot, and especially in the northern hemisphere, Europe, Asia, and North America. If cold wind meets warm wind, so the warm wind is coming, flowing this way, cold wind is flowing that way, warm wind will always rise. We will cover more about that again in the physical geography course. You don't have to learn everything at once, but for now, just believe me, warm air rises if it meets cold air. Somewhere, when it cannot rise any further, it accumulates here into what we call the jet stream. This jet stream can reach up to a speed of 300 kilometers or 190 miles per hour. And it's a sort of stream that covers the northern part and the polar jet stream. That is somewhere between the 60th and the 40th degree latitude north. And this is way stronger than the subtropical jet stream. And this has a huge effect on temperature. So here you see this polar and this subtropical jet stream. And what influence does this have on temperature? As we see here, north of this jet stream, the air is colder, which makes sense because this is the air that comes from the North Pole, or the equivalent on the South Pole. But there the effect is way less because there's less land. This polar jet stream is the line, the border between warm and cold air, where the warm air rises, as I just explained, and the cold air just pushes its way like a sort of a bulldozer through the landscape, through the continents, I mean. And north of this jet stream, it's always colder than you normally relatively would expect in that time of year. So in the summer it would be cold, in the winter it would be cold, but the difference, of course, in the winter it might cause freezing, and in the summer it might cause very cool temperatures. But it's all about relative comparison to the normal temperature, the normal, and that can cause anomalies. You understand that if the jet stream is not situated where you would like to be, then it has an effect on the temperature of your continental part where you live. But not only that, it also causes a lot of precipitation because surrounded by this jet stream, there's always a lot of precipitation. In the situation of the polar jet stream in North America, you see that the effects are that north of this polar jet stream, it's colder. Around this jet stream, as I explained, it's always more wet, and further south, you find the drier air. Another thing that causes temperature during the day, differences during the day. If the wind comes from the sea, it obviously it will blow towards land. If there are mountain areas next to the land, these mountain areas will cause the air to rise. Once they're over land, this is a situation where the water temperature is colder. The land is warm, so the moment the wind reaches land, it warms up. Because it warms up and we have the mountain ranges, is pushed upwards, which is a bit strange because normally if it would be pushed upward, elevation would cause a lower temperature, but because the land is way warmer than the sea, in this case, it could work like this. Eventually, the longer the air is high in the air, it's elevated, it'll eventually cool down and then descend again, which will cause a cooling down effect on land. If the same thing would happen in the same area, the land would cool down very quickly because land warms up way faster and cools down way faster than sea, and then you get the opposite situation. Valleys also influence the temperature. If, for example, the warm air flows through a valley, it is pushed upwards because of the topography of the mountain landscape, and that will cause the air to rise, which could also cause precipitation, but we're not talking about that. So warmer air in the valley can cause warmer temperatures higher up in the mountains. But at night, if this warm air disappears because there is no sun anymore, so there's nowhere where the warm air can come from, this air that all accumulated in these mountain ranges will cool down, and if air cools down, it will sink. That's a standard condition. If air cools down, it sinks. And then you get cooler air in the valley. So if you live in a valley, during summer days, it can be very nice and cozy and warm in the valley, even very hot in the valley, but very cold in the evening. And the last thing, that is cities, the urban heat island. We all know that heat is trapped, for example, within bricks or black rooftops. And the more black the color is, the more dark a color is, the more it absorbs the sun energy. That sun energy is stored within these buildings, within these materials, and then after the sun disappears, it will radiate, but not all of it will radiate. They calculated that if in a city like Rotterdam, all rooftops that are black would turn into green rooftops, which means that they would be turned into gardens or whatever. Not all buildings are appropriate to do that, so that's why they haven't done it, and it also costs a lot of money. But it would result, a city like Rotterdam in the Netherlands would result into a temperature drop of 2 to 3 degrees. That shows how much energy is stored just on rooftops only, and not even on the bricks, in the bricks of a town. So towns, cities, the bigger the city is, the more effect it has, have an effect on the temperature. These were the main temperature factors. Please do read the book if you didn't understand, or watch YouTube. There's also in the study guide, there's a video link that you can use for some more explanation. This was quite a long video, but I hope it helped you a little bit.